R is having a very wider community. Again, it's a compared to the Python, R has a wider community. The only thing is not mostly not customizable. Mostly meaning that it can be customized. It can be customized for some extent. The biggest problem and the challenging is integration. Integrating with applications not so easy as Python. Here understand, I am not saying that it cannot integrate it with other applications, but it is having challenges while integrating. So that was one of the reasons the people are moving out, and also less supportive packages. Right. Now, what about SAS? Again, this R is again free source. What is this? Free source. So we have both Python and R are free sources. We have, what is this? Python versus R is both are resources. You can use it anywhere, anything. And what about a SAS? It's very powerful analytics tool, and it can integrate the only reason is it's not resource. Right. You got the clarification, right? What is this? What Python and R and SAS. Suresh, I would like to ask you, can we use the C, C++, Java, whatever, right? No, I am asking myself question. Can I use C, C++, Java? Yes, absolutely. Because here it takes longer time to create code the programs, whereas in Python it's easy to code. So you can write it. There is no restriction that data science is required. Nobody has said and nobody has been fixed that way. You can write in Java also, you can write in this and everything. So apart from this programming thing, I told you right here, the data science is not traditional software programming. It's not traditional software engineering. If I talk to me, it requires lots of mathematical skill. So it required statistical skills. Right. Why I am talking about this in the mathematical skill? We'll talk about this because we have a huge data and we need to do the computations. How do you do computations? Computations can be done with multiplications. Let us take this as an X, this as a Y. This is 1 million rows. This is 1 million rows. Again, if you want to do compute manually, it takes more time. So we need that way. We use linear algebra extensively. Without linear algebra, there is no machine learning at all. So what is the scope of then statistics? Are we gonna use statistics in machine learning? I'll tell you. I'll gonna clarify the statistics and probability is important, and linear algebra here itself, because this is very important. There is a myth that statistics only required. Okay, statistics only gives you the information by doing some calculations, not most of the calculations. We can and you cannot take the decisions on the statistics, and we need the probabilistic also. We need to take the probability consideration. Probability is essential for writing your machine learning applications. Here this gives you only the inferences. What is this? Inferences. I can take this. Okay, this is what. Okay, let me tell you. In this particular area, these are the sales. Okay, this is only the information I've got. But statistically, I need to take a decision that where I can launch this project here or not. That's where we do use the linear algebra and matrix, vectors, and calculus. Very, very, very important to do calculations and understand the problem. If you have any doubt, we can discuss now. Here, you can unmute yourself. I'll just pause here for 2 minutes. You can unmute and you can ask the question. The scope is statistics are important. Stats and linear algebra is very equal important. If stat is 50%, linear algebra also is 50% important. Without this, linear algebra will not build machine learning at all. Any doubt here? Sharath? Sharath, any doubt? Okay, let me discuss about this. I'm just trying to launch my now what we are gonna discuss here, what we are gonna cover here in this course. We are gonna cover Python, we are gonna cover linear algebra with calculus and applications, where we need this and where we need the calculus. It's not about learning the formulas and moving out. We will see the applications where this linear algebra is employed in the machine learning. We do learn about statistics. We do learn about machine learning algorithms. We do learn about deep learning algorithms. It's exclusively. It's not about the intro. It's giving like end-to-end in deep learning, and the most of the NLP applications. Like we do deliver the NLP in detail, and we do build the computer vision applications. Computer vision. These are the course we are gonna cover. This course will go on for 3 months, and like every day, it's like initially we'll go 2 hours. Once we start the pace, then we increase to 2.5 to 3 hours per day. Now, let me talk to you in the other things, like how does life cycle in software engineering. Right? Life cycle software and engineering. What we do? Requirement gathering and designing a spec, designing the high level document, and design low level documents, then build, then deploy, and then maintenance. This is the typical life cycle of SDLC. SDLC stands for software life cycle. Is the same is followed in data science also? What is the data science life cycle? If you ask me, data science life cycle is completely different actually here. Here, once you deploy the model, it's your done. If any bugs comes into the picture, then only it comes to the maintenance, right? I have developed an application, I deployed into the production. We look after this into the business, we look into these applications once we get the any issue in production. This is how the normal life cycle works. Now it comes to the data science. What is the life cycle? First, foremost is problem statement. What is my problem statement? What am I want to achieve the goal? This is my first and foremost important thing in my data science. There one scientist said that well-defined problem is %100% solution. You are getting my point. Once I define the problem is 100%, like what I wanted to achieve, my goal is very clear to achieve to something. We will do this so that I know what my problem is all about. So there is a solution with me. Agree or not agree? This is what the problem statement is all about. The first is problem statement.